Here we have AP calculus AB problem. Okay, let's go to the question. Find the indefinite integral. Remember to use absolute values where appropriate. Use C for the constant of integration. Here we have a function that is 1 over x to the power of 4/5 times 8 positive x to the power of 1/5, and we have to integrate this function with respect to x. Okay, here to get integration of this function, what I'm going to do is I'm going to use a method of substitution. How can I know that I have to use method of substitution to get integration of this particular function? So usually to use method of substitution, what we have to do is we have to look at a thing in the given function, that is whether the derivative of a part of the function is multiplied in the function itself. So let's consider this particular part of the function. What is its derivative? When I find derivative of this expression, 8 is a constant, it will become 0. When I find derivative of this one, I'll be getting 1 over x to the power of 4 over 5. That's exactly what we have over here. So the derivative of the part of the function is multiplied with the function itself, and we must be able to write this derivative along with the x using multiplication. So if you are able to do the stuff what I've explained so far, so we'll be able to use method of substitution to integrate the given function. Okay, first let me arrange the terms of this function over here. So integral 1 over 8 positive x to the power of 1/5 times 1 over x to the power of 4/5 times dx. Okay, here if I consider the derivative of this particular part, its derivative is 1 over x to the power of 4 over 5, and we can write this derivative along with dx using multiplication. So we can use method of substitution in this particular integration. So what do we have to do in the first step? For that, what we have to do is we have to substitute a new variable for the part for which we have derivative. For this part only we have the derivative. So for this part we have to substitute a new variable. Usually it's u, because usually it's called u substitution. So now let me substitute a new variable u for this particular part, that is 8 positive x to the power of 1 over 5. Okay, since I have substituted a new variable u for this particular part, I have to change the complete integration in the new variable u. So since I'm going to change the complete integration in the new variable u, so instead of dx we must have du. So if I want to get du over here, so what should I do with this u? I have to get the derivative of this u. So since I have the original problem with respect to the variable x, now I have to find derivative on both sides of this equation with respect to x. When I find derivative of this u with respect to x, I am getting du over dx. When I find the derivative of this constant 8, it will become 0, and we can find the derivative of this one using the power law of derivative. That is, we have to bring this exponent in front of the variable and subtract 1 from the exponent. Then I am getting 1/5 times x to the power of 1/5 negative 1. Du over dx equals to 1/5 x to the power of. Now we have to simplify the stuff over here. That is, we have to do subtraction between the fraction and an integer. Whenever I want to do subtraction between a fraction and an integer, what I have to do is I have to multiply this integer 1 by the denominator of the fraction. Once I'm done with this multiplication, I can take this 5 as a common denominator. Let me show it over here. 1 negative 5 over 5. I just multiply this 1 by the denominator of the fraction. Now if I simplify this 1 negative 5, I'm getting negative 4/5. So the simplification of this 1/5 negative 1 is negative 4/5. Let me write it over here. So we have negative 4/5. Okay, since the exponent over here is negative, we can move this term to denominator to make this exponent as positive. So then I'm getting du over dx equals to 1 over 5 times x to the power of 4 over 5. Now to solve for du, what I have to do is I have to get rid of the dx in denominator. For that I have to multiply both sides by dx. Okay, let me multiply both sides by dx, and then the dx over here will cancel out. Okay, let me continue the result over here. Du equals to 1 over 5 times x to the power of 4 over 5 times dx. Okay, here when I consider the integration over here, I have the stuff 1 over x to the power of 4/5 times dx. So here also almost we have the same stuff, but additionally we have 5 in denominator. So we have to get rid of this 5 in denominator. For that I have to multiply both sides of this equation by 5. When I do so, this 5 will cancel out. Then I'm getting 5 times du equals to 1 over x to the power of 4/5 times dx. Okay, now let me go to the integration over here. So which is equal to integral 1 over, instead of this 8 positive x to the power of 1/5, we can plug in u, because this is a variable we have assigned for this stuff. So instead of this we can write u, and instead of this one, that is 1 over x to the power of 4/5 dx, we can write 5 du, because this is a 1 which is equal to 1 over x to the power of 4/5 times dx. So let me write 5 times du. So here this is a function. In this function 5 is multiplied over here. In integration, whenever there is a constant term multiplied by the complete function, what we can do is we can move this constant out of the integration. Then I'm getting 5 times integral 1 over u times du. Okay, 5 times. The integration of 1 over u is a natural logarithm of absolute value of u positive, the constant of integration c. So here whatever stuff we have in denominator, that is taken over here, but along with the absolute value. Why we take absolute value for this over here? Because logarithm is different only for the positive values, not for negative values. So in case if u is negative, then this natural logarithm becomes undefined. So even if u is negative, it has to be considered as positive. For that purpose only we are taking absolute sign over here. Actually, u is a variable taken by us. It has to be replaced by the original stuff, that is 8 positive x to the power of 1/5. Okay, 5 times ln. So now I'm going to plug in 8 positive x to the power of 1/5 for u over here. Then I'm getting 8 positive x to the power of 1/5 positive c. So this is the result of the given integration.